So now we're going to talk a little bit about duct sizing and how that is important when you're looking at air distribution throughout your house. The first thing to consider is you'll want to make sure that you've had a manual J load calculation done on your home. That will tell you how much CFM, cubic feet of air per minute, needs to go into a particular room for it to be comfortable. Once you know how much CFM needs to go everywhere, you can then start sizing your ductwork appropriately to deliver that amount of CFM. And it's not just a one-size-fits-all type of thing. You know, a 7-inch duct could take 100 CFM someplace, but if you're not looking at the system as a whole, it's really difficult to say how much a 7-inch duct is going to deliver to a room. So you can see here I've got this larger duct that's a flex duct. Well, this is going to be able to deliver more air than maybe a smaller duct that's metal. You know, it all depends on the type of duct, the compression ratio, how much compression there is in this flex, and then also the size corresponding with all of the other elements in the system. It all goes together. So things that will affect duct sizing going to a particular room could be that your room is way off on the other side, you know, 100 feet away from wherever your air handler is. Or maybe there's some snaking that it has to do to get between floors and around trusses and things like that. All of those things need to be taken into consideration when putting in the right size duct. Again, you want to limit the amount of kinks and turns and bends and U-turns and crimps and extra ductwork being compressed and all of those things, but it should all be calculated out so that you get the right amount of air going to the right place. So we're now looking at some ductwork, looking at duct design and how this might affect air distribution. This is a very common setup. We've got an attic unit here that's horizontal, and we've got the furnace down there, the coil here, and then this is the supply plenum. And this is a supply plenum that's duct board with these, basically it's got these starting collars that hook up to this flex duct that goes off to all sorts of different parts of the house. And so where you put your flex duct on this supply plenum affects how much airflow is going to come out. So the idea is that this plenum is going to be equally pressurized, right? In theory, the plenum is pressurized equally, and then the duct sizing determines how much air goes to which room or place from there. And the issue with this particular situation is they have ducts coming off the end of the plenum. And the problem there is that the plenum now can't pressurize. All of that air just goes straight down and straight through the ducts that are on the end, which actually sort of starves the ones that are at the beginning because there's not an equal pressure buildup inside the plenum. Ideally, you want a third of the plenum in the beginning to be completely blank, left alone for the air to sort itself out when it comes out through the coil. Then you want a third of the plenum at the end to be blank again so that there can be a good pressurization zone so that everything gets evenly pressurized in the middle third, which is where you're going to put all of your ductwork. And when you put your ductwork on, you really want to stagger it and you want to separate them as much as possible so that they aren't fighting for the air and that one doesn't get an unequal amount of air than the other. So all of those things are ideally what you want to do. But you can see in this particular environment, you can never build ideally. You just want to sort of strive and know what's best practices and what a good design can do. So in this situation, they had to have all of their ducts coming off the top. They only had this much room to put the ducts in, so it ended up rather cramped. So you can see that this is a pretty typical design, and it's also very common practice to sort of leave the mechanicals till the last minute. But the more forethought that we can put into our buildings and really get the proper design and leave space for our mechanicals, the more efficient it's going to be, and it's also going to allow your contractor to do a better job of sealing up the ductwork, installing the ductwork correctly, that sort of thing. So providing access is another key point to the design. If I can reach every part of the duct, then chances are I'm going to be able to seal it correctly. I'm going to be able to install it without kinks or compressions or things like that. So leaving space is always a good idea. And I know that that's an expensive proposition because there's always trade-offs and who gets the space and where, but once again, proper design, you don't need to add more space. You can just use it more efficiently. So another thing to talk about when it comes to air distribution is return and return sizing. Making sure you have enough return is really important because you don't want to starve the fan. You know, imagine running a marathon only sucking through a coffee straw. You're not going to get the performance out of your lungs that you would like, and that's the same thing with air conditioning systems. So This needs to be properly sized, not just this grill, but the actual duct that goes off behind it back to the unit. You want to make sure that that this grill is approximately 200 square inches per ton of return that you have. And the reason why you want that is to eliminate any static pressure that might build up in the system and cause the fan to work harder than it has to. So with an undersized return, like you might think, you're probably going to get less air coming out of the supply ducts when there's less air that can go into those supply ducts. So making sure that you have an accurate size return really helps with air distribution. So something else that's really important to remember is when you're talking about returns and how they affect airflow, having a clean air filter in there is obviously going to be the most ideal thing for not blocking the air but still filtering the air that you've got. So if you've got a media filter in the unit, for example, you need to make sure that the homeowner is aware that those things need to be changed because it definitely affects the airflow that comes out. Possibly up to even a ton. A clogged coil or a clogged air filter or something like that can affect it as much as 25% of your airflow being blocked just because there's another blockage in the way of that air getting through your system. So if you have a media filter, if you have filters that are actually just at the grills, either way you need to make sure those things get changed or that there's some sort of plan in place to make sure that those things will either get changed or they're the right type of filter that isn't going to impede the static pressure and the performance of the unit. So with air distribution, the most important part is balancing the system. And that means that the HVAC contractor is going to balance and actually measure the amount of air coming out and making sure that that is in accordance with the manual J and what the duct design said was going to happen when you get into that room. So even if you have the right duct size going someplace, it doesn't mean that you're going to get exactly the right amount of airflow to that room, which means that you need to install a series of dampers in some places to shut the air off in one place so you can push that air to another place that needs it more. And there's a whole bunch of different ways to damper a system. The best way to do it is as far back closest to the system as you can get. So if you're looking at what we just saw a minute ago with a standard supply plenum like a ductboard plenum coming off and then ducts going off of that, if that's your setup, you're going to want a damper at that plenum. So you've got starting collars like this that attach to the plenum, and inside here can be a movable damper. And this damper is the best place to control the airflow because it's right at the plenum. Any air that's going to get deflected is going to immediately go into another part of the duct, pressurizing the plenum some more, that sort of thing. So this is the ideal place to close off a vent, essentially increasing the velocity. Because another thing you want to take into consideration is noise. If you were to not damper here and damper closer to the unit, closer to the room, in the back of this supply duct right here, you could put a little tiny damper inside here. And the problem with putting a damper in the supply bucket is this is going to increase the velocity coming through here. So the air speed is going to increase, but the volume of air really isn't going to increase that much. And so when you increase the speed like that, when it passes by a metal louvered grill or something like that, it could start whistling. It could, create all sorts of noise issues or make it sound like it's cooler than it actually is in that room just because of increasing the velocity. So again, to reiterate, you always want your dampers as far away from the living space as possible. Not just from an aesthetics and from a sound perspective, but also an efficiency. If I blocked off here, then this whole duct is going to be then pressurized back to the unit, and it's a less efficient way of doing things. So ductwork takes up a lot of space in your buildings between floors. We get it. It's really hard to accommodate all of those thick pieces of tubing that are going everywhere. But the reason why this is important to accommodate these things is because ultimately this is what's going to make your homeowner comfortable. So if you have, let's say duct going between floors, it's going to make a kink down like this to make a U-turn. And I don't know if you can see that, but that's a lot of air restriction in this kink. So you want to keep these sorts of kinks to a minimum. And you can see inside here, that's reducing the passageway for the air. Kinks are something I see quite often in the field. One way to get around some of these kinks is to have the ductwork properly supported. When it's suspended through the attic, it should be supported every 5 feet, and there shouldn't be any dipping in between. It should just be a straight line through the supports. Because you can imagine a dip in this, and you have one of those every 5 feet or something. All of that compression adds up and builds up resistance to the air that's going through it. Same thing with U-turns in ductwork. This is just a lot of wasted ductwork and wasted energy to get the air from one side to the other when it has to make a U-turn, when it probably could have just gone straight to the first place. So one of the last things that you want to consider when you're looking at avoiding pitfalls with air distribution in your home is to look at the way you're actually putting the air into the space. So there are 3 different ways to do that, in a sense. There's through a grill, through a diffuser, and then also through a register. And all of those 3 things are slightly different in how they do what they do. So when we're talking about a grill is literally just basically sheet metal that's been pressed out, so where there's one flat fin coming out that directs air in that way. It's a very simple way of looking at how air is going to get into the space. So then when you look at a register is going to be able to direct the air a little bit into its own path, wherever that may be. But the thing that it lacks is what the diffuser has. And the diffuser can diffuse the air on the back side. You can see these fins here closing, not letting air through as readily as when it is open. So all of those 3 things do things a little bit differently. The most control you can have is with a diffuser, and this one in particular is a curved vane diffuser. And these curved vanes allow you to mount this on the ceiling, and the air comes out and sort of circles along the ceiling and then falls down. And the idea there is that you're cooling the room without blowing a bunch of uncomfortable air on someone. And in cooling climate zones like in Austin, Texas, where we are right now, this is the best way to deliver air into the room, because the cold air is then going to fall down. If we're in a heating climate, say up north in New York or something, we would really want the air to come from the bottom and have the heat rise up naturally. So this is very dependent on what climate zone you live in as well. There are also different types of registers. This one in particular is more necessary on a wall-mounted register, and the reason why is you can see it doesn't have any curved vanes because we actually want to shoot the air out away from the wall at this point. So that's what this one would be used for. Another example here are these slot registers, and these typically get mounted in the ceiling and then just let air out through these small slots. This is very aesthetically pleasing. And your HVAC installer will know the different resistances and what size grill to put in for your particular project. So some of the cheaper grills and registers that you can buy actually block some of the air from coming out. You can see here that about 50% almost of the surface area is blocked by the actual register itself. And the problem with this is you can then have pressure building up on the back side of this where the air isn't coming out. Almost as much as 10 CFM sometimes is stuck behind this register and not coming out the other side. When static pressure builds up like this, that connection where the supply bucket meets the sheetrock is then under a lot of pressure, and the air can leak out around that seam if it's not sealed properly, once again affecting your airflow into your house.